Light, the more the clocks on your ship slow down. So time to you passes more slowly. So if you have somebody approaching the speed of light, say 80 or 90% of the speed of light, time for them is passing very, very slowly.
If a rocket blasted off from Earth on a round-trip mission to Alpha Centauri, traveling close to the speed of light, years would pass here on Earth before the mission's return. But on the spaceship, only a few weeks would have elapsed. The crew would have aged only a few weeks, and the flight recorder would indicate a short journey.
It's not science fiction, it's really true. We can test this in undergraduate physics laboratories around the world every single day, and it works. It's really true that clocks do slow down relative to an observer watching someone as they travel near the speed of light. Now, this is, in principle, of course, great. But it's also a problem if some spacecraft does a return voyage and it takes 5 years for it to do, and 50,000 years later it arrives back at its home base.
But there is an even bigger problem. Our ship can only go so fast before it runs into Einstein, the ultimate galactic traffic cop. Einstein says there is a universal speed limit. It's not possible to travel faster than the speed of light, because at that speed, the laws of physics fundamentally alter mass.
As objects speed up to get closer and closer to the speed of light, they get more massive. If I take a single atom and I want to accelerate it to half the speed of light, using conventional rocket fuel, the amount of fuel required will be greater than the mass of the entire visible universe.
Our spacecraft, being made of atoms, would have the same problem. The closer the ship gets to the speed of light, the more massive it becomes, until ultimately, according to Einstein, it becomes infinitely massive. This is the mind-boggling relationship between energy and mass that Einstein grasped a century ago, and the rest of the world has been grappling with ever since. And you might think that such physics would prevent our aliens from traveling across galaxies. Clearly they're not, because our aliens have found a loophole in Einstein's general theory of relativity. Well, it's actually not so much a loophole as a wormhole. There may be a detour around the speed of light. The team is busy analyzing the exterior of our alien ship, even as we struggle with its gears and inner workings. And our technicians have made a major discovery. They've tapped into what we would call the ship's computer guidance system. It appears there's a map of the universe. This could be a real breakthrough. Contrary to what we learned at primary school, the shortest distance between 2 points isn't necessarily a straight line. To begin to understand what the aliens are doing, we again have to consult Einstein about his theories on gravity.
Einstein saw mass and space, matter and space, as connected in the sense that you could explain gravity by saying that mass distorts space, that it exerts some force on it. Space is curved in the vicinity of matter, and that the planets follow the shortest path on the curved surface of space.
So massive objects bend space itself. Proof of this bizarre theory, which secured Einstein's place among the gods of physics, was produced by 2 expeditionary British astronomers in 1919. The scientists took photographs of the sun during a solar eclipse. Within the darkness, as the moon shields the sun, stars near the sun are visible. But Einstein believed that some stars behind the sun would also be visible. He predicted their light would be curved by the sun's immense gravity around the sun, and therefore be visible to us beyond its edge.
He actually calculated by what amount it would curve, and in 1919, British astronomers went to see a solar eclipse and verified precisely that his prediction was correct, and Einstein became a household name overnight.
Since gravity bends space, the aliens might be utilizing that phenomenon to jet across the galaxy. This device appears to be a warp drive.
If you could manipulate space, you could expand space behind you and contract it in front of you, and you could build what you might call a warp drive, if you wish, which in some sense is warping space by manipulating it in front and behind you, and in so doing, travel from one place to another, apparently faster than the speed of light.
By constricting space-time in front of the vehicle, while expanding space-time behind, the alien ship can be propelled like a bullet exiting a rifle.
And even better, the clocks inside would run at the same rate as the clocks outside. This is probably one of the most surprising and puzzling things, but it would live in a pocket of ordinary space which wouldn't feel the relativistic effects of its huge velocity.
Having successfully hacked into the alien computer system, our engineers are learning a lot about the function of the ship. Next to the warp drive is an even more sophisticated device. It too allows for faster-than-light travel, relatively speaking. A wormhole generator, capable of folding space itself.
Think of Alice's looking glass. The looking glass was in some sense a shortcut, a subway system, a tunnel through the fabric of space and time. That is a wormhole.
Let's imagine a map of the Earth. Mark A represents New York City. Mark B represents Paris. If we fold the map, they're actually not very far away. Now all we need to do is punch a hole through the map to connect both cities. Voila! The opening is like a wormhole.
In 1935, Einstein came out with the first paper on wormholes. We call them Einstein-Rosen bridges. We don't really call them wormholes. But these Einstein-Rosen bridges really do take you from one stage to another. A gateway.
Einstein's theory allowed for the possibility of wormholes. Quantum physics suggests they may occur spontaneously.
Einstein's equations, we now know, are littered with wormholes. It's impossible to look at Einstein's equations without finding a wormhole here or there. They're everywhere. The problem is, how stable are they?
Luckily, the wormhole generator also has a stabilizer. That means the aliens can prop open a wormhole and keep it open until the ship passes through. Problem solved. Understanding this alien ship has been a real challenge. We've had to push our knowledge of physics and quantum mechanics to its limit in order to comprehend what our alien visitors have achieved. But we've been able to work out quite a bit. Like how it defies gravity and inertia, and how it can sidestep the speed of light to cross the universe. The next challenge is turning this insight into our own real machines that can travel through space and time. To meet the aliens on their turf, not as students or subjects, but as equals.